we needed more power in electrification or in the electrical motor if we only had one motor. So hence, we came up with the dark matter. It features our Raxial flux technology that we patented for the Quark e-motor, but it now has 6 phases. It's the world's first 6-phase e-motor for automotive use.
Imagine a motor so small it could fit in your backpack, yet so powerful it could launch a 4-seat car faster than a Bugatti. No gears, no noise, no wasted energy, just pure, controlled force. Sounds impossible, right? But that's exactly what Sweden's most secretive engineer has built. It's called dark matter, and it's about to shake the foundation of the entire electric car industry. How did Koenigsegg do it? And why are companies like Tesla and BYD suddenly watching closely? Stick with us to the end to find out. The engineer who builds the impossible. While Tesla was becoming a household name and legacy, automakers poured billions into electric dreams. One Swedish engineer ignored the entire playbook. Christian von Koenigsegg doesn't chase trends, he breaks them. He builds what others say can't be built, and when he's done, the impossible looks routine. His story doesn't start in a family garage or an engineering lab. It begins with a 5-year-old boy in Sweden who didn't just play with toys. He took them apart to understand how they worked. At 5, he made a declaration that most adults dismissed as fantasy. I'm going to make the fastest car in the world. 40 years later, he proved it. In 1994, with no investors, no factory, and no reason to believe it could work, he founded Koenigsegg Automotive, a supercar company born from obsession, not opportunity. When he unveiled the CC prototype, experts couldn't believe it was real. But it was, and it marked the start of a new kind of competition, one built on precision. That precision has created some of the most radical automotive breakthroughs in modern history. When others added gears, Koenigsegg removed them entirely with direct drive. When others made engines bigger, he shrank them and replaced camshafts with free valve technology, software-controlled precision that redefined efficiency. While others relied on steel, Koenigsegg built carbon fiber monocoques so strong they changed crash safety standards. Every invention came from one question: why are we doing it this way? That defiance turned a small Swedish workshop into a company that makes Ferrari cautious and Bugatti nervous. From the CCR's world speed record to the Gemera RS hitting 277.9 miles per hour and the Regera's gearbox-free hybrid system, Koenigsegg has never stopped pushing boundaries. Yet for Christian, speed was never the goal, it was proof of concept. So while the auto world rushed to chase electric power, Christian asked a different question. What if everything we think we know about electric motors is wrong? That single question led to years of secret development. The result was a machine that broke every rule of electric propulsion. They called it dark matter, and when they finally revealed the specifications, competitors checked their math multiple times because the numbers seemed impossible. Why dark matter means more than you think. Koenigsegg could have named their motor power core or hypervolt like everyone else, but they chose dark matter for a reason that reveals everything about what they built. In physics, dark matter is the invisible force holding galaxies together. Scientists know it exists because they can measure its effects. Galaxies rotate, stars orbit, entire cosmic structures hold their shape, but they can't see it, touch it, or directly detect it. Dark matter makes up most of the universe's mass, yet it remains completely hidden, influencing everything around it through pure, invisible strength. Koenigsegg's motor works the same way. It's compact enough to hide in places you wouldn't expect. It runs silently, producing no engine roar and no mechanical drama. From the outside, it looks unassuming, almost ordinary. But the moment it activates, everything changes. The car doesn't just accelerate, it transforms, launching forward with a force that feels supernatural because there's no warning or sign of sound preparing you for what's about to happen. Most electric motors telegraph their power. You hear cooling fans spinning up, feel the weight of massive battery packs beneath you, and sense the physical bulk of the drivetrain. Dark matter eliminates all of that. That's why the name isn't marketing creativity or clever branding. It's technically accurate. Like cosmic dark matter controlling galactic motion without being seen, Koenigsegg's motor controls the Gemera's movement without the bulk, weight, or noise that typically accompanies this level of power. And once you understand what dark matter truly represents, the next question becomes inevitable. How powerful is it really? The specifications that break the rules. Imagine lifting an engine that weighs as much as a carry-on suitcase, yet produces 800 horsepower and 1,250 newton-meters of torque. That's the dark matter motor, a 39-kilogram powerhouse that embarrasses electric motors twice its size. Here's where physics should have said impossible, but Koenigsegg's engineering team apparently didn't get the message. Those numbers sound wrong because they violate everything the automotive industry has accepted as normal for electric motor design. The power-to-weight ratio tells the real story. Dark matter delivers approximately 20 horsepower per kilogram. Think about what that means. For every kilogram of motor weight, you get 20 horsepower of output. Most electric motors in production vehicles manage between 2 and 3 kilowatts per kilogram, which translates to roughly 3 to 4 horsepower per kilogram. Dark matter multiplies that standard by 5. Tesla's Model S Plaid uses 3 electric motors to achieve its performance. Each motor weighs approximately 30 kilograms and produces around 300 horsepower. That's 3 motors totaling 90 kilograms, delivering 900 horsepower combined. Dark matter produces 800 horsepower from a single unit weighing 39 kilograms. One motor does what takes Tesla 3, and does it with less than half the total weight. The Rimac Nevera, currently one of the world's most powerful electric hypercars, uses 4 motors producing a combined 1,914 horsepower. Combined motor weight exceeds 150 kilograms. Dark matter produces nearly half that power at roughly 1/4 the weight. The efficiency gap isn't incremental, it's generational. Look at the Porsche Taycan Turbo S, widely respected for its engineering excellence. Its motors produce a combined 750 horsepower from units weighing approximately 100 kilograms total. Dark matter exceeds that power output while weighing 61 kilograms less. The weight savings alone could improve handling, reduce energy consumption, and allow engineers to optimize vehicle balance in ways that weren't previously possible. But raw power numbers only tell part of the story. Dark matter's maximum rotational speed reaches 8,500 revolutions per minute. That responsiveness means instant torque delivery across the entire rev range with no lag, no buildup, no waiting for turbos to spool or gears to engage. Press the accelerator and full power arrives immediately, maintained consistently until you lift off. The motor's physical dimensions are equally absurd. It measures 15.1 inches in diameter and 5.3 inches thick. You could stack 3 of them and still have less height than a standard car tire. Yet this compact package handles electrical loads that would overwhelm motors twice its size, sustained thermal stress that would cook conventional designs, and magnetic forces powerful enough to tear lesser components apart. Compare those dimensions to typical EV motors. The Ford F-150 Lightning, an industrial-grade electric truck designed for hauling and towing, uses motors that are significantly larger and heavier than dark matter, yet produce less peak torque. The Lucid Air Sapphire, a luxury performance sedan, uses 3 motors that combined are larger and heavier than dark matter while producing comparable power. Koenigsegg isn't just improving on existing designs, they're operating in a completely different category. These specifications demand an explanation, and that explanation lies in technology the automotive industry hadn't seen before. Koenigsegg invented it. Raxial flux, the technology that didn't exist. Koenigsegg didn't just build a better electric motor, they invented an entirely new category that combines 2 opposing designs into something neither could achieve alone. Electric motors have traditionally followed 2 distinct architectural approaches, each with clear strengths and unavoidable weaknesses. Understanding both explains why Koenigsegg's hybrid approach represents such a fundamental breakthrough. Radial flux motors are the most common type, found in everything from power tools to Tesla vehicles. In these motors, the rotor spins inside the stator, with magnetic flux lines radiating outward from the central axis like spokes on a wheel. This design is mechanically simple, relatively easy to manufacture, and scales well for mass production. The drawback is size. To increase torque, you must make the motor longer, which adds weight and creates packaging challenges. Radial motors excel at high-speed operation but struggle with torque density, producing less rotational force per unit of volume compared to other designs. Axial flux motors take a completely different approach. Instead of wrapping the stator around the rotor, axial designs place them face-to-face in parallel planes like 2 discs with magnetic forces acting parallel to the axle. This pancake-shaped configuration delivers higher torque density in a more compact form factor. The magnets and coils can be larger in diameter, creating more surface area for magnetic interaction. But axial designs have their own limitations. They're more complex to manufacture, harder to cool effectively, and typically don't handle high rotational speeds as well as radial configurations. For decades, motor designers chose one path or the other based on their priorities. Radial for high-speed applications, axial for high-torque needs. Koenigsegg refused to choose. They merged both approaches into what they call Raxial flux architecture, a term they coined because no existing vocabulary described what they'd created. Dark matter's Raxial design layers rare earth magnets in a configuration that generates both radial and axial magnetic forces simultaneously. The rotor and stator interact in multiple planes, channeling magnetic flux in two directions at once. This allows the motor to capture the high-speed capabilities of radial designs while maintaining the torque density advantages of axial configurations. The result is a motor that delivers maximum torque across the entire RPM range without the compromises that plague traditional designs. The engineering challenge was immense. Managing magnetic forces in two planes simultaneously requires precise control of field interactions to prevent interference and energy loss. Koenigsegg solved this through advanced finite element analysis and iterative prototyping, mapping every magnetic field line to optimize flux paths and eliminate dead zones where energy would dissipate as heat rather than producing useful work. The material selection was equally critical. Dark matter uses rare earth neodymium magnets, among the strongest permanent magnets available, arranged in precise geometric patterns that maximize magnetic field strength while minimizing weight. The stator windings use high-grade copper with optimized conductor cross-sections, balancing current carrying capacity against resistive losses. Every component is constructed from aerospace-grade materials. The rotor uses carbon fiber reinforced polymer capable of withstanding extreme centrifugal forces at 8,500 RPM, while the housing employs carbon fiber composites that provide structural rigidity while dissipating heat efficiently. This construction achieves efficiency levels approaching 95% under optimal conditions, meaning only 5% of electrical energy converts to waste heat rather than mechanical work. Compare that to typical EV motors operating at 85 to 90% efficiency, and the advantage becomes clear. Higher efficiency means less energy wasted, smaller cooling requirements, extended range from the same battery capacity, and sustained performance under loads that would force conventional motors to throttle back. And just when you think you've grasped how this thing works, Koenigsegg adds one more layer. Because hidden inside dark matter is a feature so strange, it breaks the rhythm of every electric motor before it. If you're impressed so far, hit that like button. It helps us to reach more car enthusiasts like you who love stories of true engineering rebellion. Now let's unravel what makes this motor smoother, stronger, and far smarter than anything else on the road. The six-phase power mechanism. While the entire EV industry runs on three-phase power because that's how it's always been done, Koenigsegg asked a simple question: what if we doubled it? Understanding why six-phase power matters requires understanding how electric motors actually work. Every EV motor relies on electromagnets in the stator that switch on and off in sequence, creating rotating magnetic fields that pull the rotor around. The more phases you have, the smoother that rotation becomes, and the more efficiently power flows through the system. This setup has worked fine for decades in industrial applications and mainstream electric vehicles. It's proven, reliable, and relatively simple to control. But it has limitations that become apparent when you push power density to extremes. Under heavy loads, three-phase systems experience torque ripple, small fluctuations in rotational force as each phase takes its turn driving the rotor. You feel this as a slight pulsing sensation during hard acceleration, that subtle vibration underlying the power delivery. Three-phase motors also concentrate current through fewer pathways, which generates more heat per conductor and requires more aggressive cooling. If one phase fails, the motor loses 1/3 of its capacity immediately, and continued operation risks damage to the remaining phases. Koenigsegg's six-phase architecture changes the entire equation. Instead of 3 electrical phases, dark matter uses 6, arranged as 2 sets of 3-phase windings offset by 30 degrees. This effectively doubles the number of current pathways, pushing the rotor at any given moment. The benefits are seen through every aspect of motor operation. Torquey ripple disappears almost entirely because 6 phases create such smooth, continuous rotation that fluctuations become imperceptible. Current is distributed across twice as many conductors, so each wire carries less amperage, generates less heat, and operates further from its thermal limits. This improved thermal performance means the motor can sustain peak power longer without triggering thermal protection that would reduce output. 6-phase systems also handle faults more gracefully. If one phase fails, 5 others continue operating, and the motor maintains approximately 83% of its power, rather than dropping to 67% as a 3-phase system would. This fault tolerance adds reliability, critical for a hypercar where motor failure at high speed could be catastrophic. This electrical sophistication required a control system equally advanced, which is where Koenigsegg's next innovation becomes critical: David and thermal control. All the power and sophistication in dark matter would be worthless without two final pieces: a brain fast enough to control it, and a cooling sophisticated enough to prevent it from destroying itself. The David inverter is that brain. Inverters convert DC battery power into AC current that drives the motor, but calling David just an inverter undersells what it actually does. This silicon carbide unit makes over 100,000 decisions per second, constantly adjusting current flow to each of dark matter's 6 phases based on throttle position, motor temperature, wheel slip, and dozens of other variables. Silicon carbide was critical to achieving this performance. Unlike traditional silicon semiconductors, silicon carbide switches faster, handles higher voltages, and operates at higher temperatures without degradation. This allows David to react in microseconds rather than milliseconds, eliminating the lag between driver input and motor response that plagues many electric vehicles. When you press the accelerator in the Gemera, David has already calculated optimal current distribution and begun adjusting power flow before your foot finishes moving. David's capabilities extend beyond simple power conversion. It manages torque vectoring by independently controlling current to different motor phases, enabling the Gemera's front axle to send more power to whichever wheel has better grip. It monitors thermal conditions across the motor and adjusts power delivery to prevent hot spots from developing. It coordinates with the Lightspeed tourbillon transmission to ensure seamless power flow during gear changes. Every electrical decision flows through David, making it as essential to dark matter's performance as the motor itself. But even the smartest control system can't overcome basic thermal physics. 800 horsepower generates tremendous heat, and in a package as compact as dark matter, that heat can become destructive if not managed aggressively. Koenigsegg developed a liquid cooling system that circulates coolant through channels embedded directly in the stator housing, just millimeters from the copper windings where heat generation is highest. The cooling circuit uses high-performance thermal fluid that absorbs heat more effectively than water-based coolants, carrying it away from critical components to external heat exchangers. The system maintains optimal operating temperature even during sustained full-power runs, preventing the thermal throttling that affects many performance EVs after repeated hard accelerations. Every design decision, from phase count to magnetic architecture to cooling circuit layout, works together to keep dark matter operating at peak efficiency under conditions that would cook conventional motors. Share this video with your friends who still think electric innovation is slowing down. They need to see what's coming next. The Gemera, where everything comes together. Koenigsegg took the world's most advanced electric motor and installed it in the last place anyone expected, a 4-seat family car that happens to outperform every electric hypercar on the planet. The Gemera looks civilized at first glance. It has 4 proper seats, with enough legroom for actual adults, not children pretending to be comfortable. It features 8 cup holders, 4 heated, 4 cooled, because Koenigsegg apparently decided that if you're building a hypercar, everyone deserves their beverage at the perfect temperature. There's luggage space in the front and rear, climate control for all passengers, and individual infotainment screens. These are details you'd expect from a luxury sedan, not from a machine capable of violating physics. But underneath that practical exterior hides something unprecedented. The Gemera is the first production vehicle powered by dark matter, and Koenigsegg paired it with engineering just as radical as the motor itself. The Lightspeed tourbillon transmission, or LSTT, is a 9-speed multi-clutch gearbox that doesn't shift gears the way normal transmissions do. It preloads the next gear while the current one is still engaged, then transitions between them so quickly that torque flow never interrupts. Every gear change feels less like a shift and more like one continuous surge of acceleration. Dark matter mounts in the front axle assembly, what Koenigsegg calls the bulldog drive unit, delivering instant torque to the front wheels. But the real power comes from behind it, where customers choose between 2 radically different combustion engines that define what kind of Gemera they want. The Gemera was initially planned to have 2 powertrain options, the 1,400 horsepower TFG hybrid system and the 2,300 horsepower HV8 hybrid system. Koenigsegg found that nearly all customers were choosing the HV8 option, which is based on a 5.0-liter twin-turbo V8 from the Jesco. As a result, Koenigsegg decided to make the V8 the standard, and currently the only engine offered in the production model of the Gemera. While the TFG engine won't be offered in the Gemera, Koenigsegg has suggested that the innovative camless 3-cylinder engine may be used for other projects in the future. The HV8 produces 1,500 horsepower and 1,500 Newton meters on its own. When dark matter joins the equation, total output reaches 2,300 horsepower and 2,750 newton-meters of torque. Those combined figures exceed every production car in history. The Bugatti Chiron Supersport produces 1,577 horsepower. The Rimac Nevera reaches 1,914. The Koenigsegg Gemera with the hot V8 leaves them both behind while seating 4 people comfortably and offering 50 kilometers of pure electric range from its 16.6 kilowatt-hour battery pack. Performance numbers reflect this absurd power. 0 to 100 kilometers per hour happens in 1.9 seconds. Top speed exceeds 400 kilometers per hour. Yet the Gemera can cruise silently on electric power alone, slip through city traffic without drama, and deliver better than 7 liters per 100 kilometers of fuel consumption when driven reasonably. It's simultaneously a hypercar, a grand tourer, and a practical 4-seater that happens to be faster than anything else on public roads. The competition that suddenly looks outdated. The electric vehicle industry has operated on one fundamental assumption, that maximum performance requires maximum hardware, and Koenigsegg just proved that assumption wrong. Tesla's Model S Plaid represents the pinnacle of the company's engineering. 3 motors, 1,020 horsepower, 0 to 60 miles per hour in 1.99 seconds. It's an impressive machine that costs $90,000 and delivers performance that seemed impossible from a sedan just a few years ago. But it needs 3 motors totaling 90 kilograms to achieve what dark matter does alone at 39 kilograms. That's not an incremental improvement, that's a generational leap. The Rimac Nevera takes a different approach, using 4 motors, producing 1,914 horsepower to become one of the world's fastest accelerating production cars. But those 4 motors combined weigh more than 150 kilograms, and the total vehicle weight exceeds 2,300 kilograms. The Gemera with hot V8 produces 2,300 horsepower while weighing less than 2,000 kilograms, achieving a superior power-to-weight ratio despite seating 4 and maintaining hybrid flexibility. Porsche's Taycan Turbo S represents German engineering excellence, sophisticated, refined, and expensive at nearly $200,000. Its dual motors produce 751 horsepower combined and deliver repeatable performance that many EVs can't match. But dark matter alone exceeds that output while weighing roughly 60 kilograms less than Porsche's motor setup, and the Taycan can't match the Gemera's versatility, range, or outright performance. The pattern becomes clear across every comparison. Mainstream and luxury EVs alike use multiple motors, accept greater weight, and are designed around limitations that Koenigsegg simply eliminated. Dark matter's power density advantage cascades through every aspect of vehicle design. Lighter motors enable better weight distribution, improved handling, reduced energy consumption, and design freedom that multi-motor layouts can't provide. Every automotive engineer who sees dark matter's specifications now knows that something better is possible, and that knowledge alone will push the entire industry toward solutions that Tesla, BYD, and other current leaders may not be prepared to deliver. The threat isn't just about cars anymore. It's about every application where electric power matters, and that's where dark matter's true disruptive potential becomes clear. Beyond automotive, the revolution nobody expected. While everyone debates whether dark matter threatens Tesla and Porsche, they're missing the bigger picture. This technology could transform every industry where power-to-weight ratio matters. At 39 kilograms and 800 horsepower, dark matter fits in spaces no conventional power unit could occupy. That combination of compact size and extreme output doesn't just change cars, it opens possibilities across industries that have waited decades for this kind of breakthrough. Aerospace manufacturers face one persistent obstacle to electric flight: weight. Batteries are heavy, and traditional electric motors are too bulky for aircraft applications where every kilogram matters. Dark matter's 20 horsepower per kilogram ratio changes that equation completely. Mount several units in a distributed propulsion system, and you could power aircraft that were previously impossible with electric technology. Urban air mobility companies developing flying taxis need exactly this kind of power density, enough thrust to achieve vertical takeoff and sustained flight, without the weight penalties that have kept electric aviation theoretical. Marine applications face similar constraints. Electric boats and watercraft need high torque for propulsion, but can't afford heavy drivetrains that raise the hull in the water and increase drag. Dark matter delivers marine-grade torque in a package light enough to mount in positions that improve rather than compromise boat dynamics. High-performance racing boats, commercial vessels, and even submarines could benefit from power units that produce this much thrust without traditional engine bulk. Industrial robotics and manufacturing automation require motors that run continuously, without overheating, deliver precise torque control, and maintain reliability over millions of cycles. Dark matter's thermal management and efficiency characteristics make it ideal for industrial applications where downtime costs money and performance consistency matters more than peak output. Heavy-lift drones for construction, logistics, and emergency services need exactly what dark matter provides: sustained high power in a weight-optimized package. Koenigsegg designed dark matter with scalability in mind from the beginning. The company already produces most components in-house, giving them complete supply chain control and the flexibility to adapt the design for different applications without relying on third-party suppliers. As production volumes increase, manufacturing costs will decrease, making the technology accessible to industries beyond automotive. Whether Koenigsegg licenses the technology, supplies motors directly to other industries, or keeps it proprietary for their own vehicles, dark matter represents a fundamental breakthrough that extends far beyond the hypercar market. The question now is, will this motor soon floor giants like Tesla and BYD? And will its technology find its way into the cars we drive every day? Drop your answer in the comments section below. Subscribe and turn on notifications so you don't miss what comes next. Because if dark matter is just the beginning, the future of performance might be faster than anyone expects. Thanks for watching. See you in the next one.